like we've just seen this small example, we are saying, okay, an apple has this size, this weight, this color. A blueberry has this size, this weight, this color. A coconut has this size, this weight, this color. So this random fruit, what is it based on what we know about apples, blueberries, and coconuts? And we've said that this particular fruit was red and it was moderately sized, but it was heavy like a coconut. So our random guess was going to give it to be like, okay, that fruit is probably an apple because it shares 2 out of 3 of the characteristics with an apple than it shares with a coconut. All right, so naive Bayes is a classification technique that uses probabilities we already know to determine how to classify the input. These probabilities are related to existing classes and what features they have. In this example above, we choose the class that most resembles our input as the classification. This technique is based around using Bayes' theorem. If you're unfamiliar with what Bayes' theorem is, don't worry, we'll explain it in the next session. Okay, so you've seen this kind of classification. So you see the underlying, all of them, like the different kinds of classifications, but all of them are trying to classify things to different categories. So I just want to make sure that we are following that these are classification algorithms, and you can see that they're trying to classify things between different categories or classes. So we first saw logistic regression, which is a binary method, classification method. And now we've seen naive Bayes, which is a technique, a classification technique that uses probabilities we already know to determine how to classify a particular input. And then now we are going to see k nearest neighbors. This is also a bit popular. Okay. So the presentment behind k nearest neighbor classifier algorithm is very simple. The algorithm classifies a new data point based on its proximity to different classes. So you can see there are different ways of how they're doing classification, but in the end they're all classifying a particular input and trying to see which classes does that input lie. So the algorithm calculates the distance between the query data point, that's the unlabeled data point that's supposed to be classified, and its k nearest labeled data points. Ultimately, it assigns the query data point to the class label that the majority of the k data points have. So this is an example. So figure 1 demonstrates the algorithm in practice. We classify the test sample, which is green, as one of the blue or red classes, considering k is equal to 3. Okay, k is like maybe n, how many neighbors are around a particular data point. So considering k is equal to 3, the 3 closest data points determine the classification outcome. Okay, so as the majority vote red category, then the algorithm assigns red as the sample class. So we're just trying to say that if you have a new data point and you don't know how to classify it, in this example, is it a blue square or is it a red triangle? So, and yet it is right here. Like this is where it exists, like that is its location. So we are going to use k nearest neighbor to classify it, and we're going to say, okay, if we use k is equal to 3, what are the closest classes that are close to it? So we are saying that if k is equal to 3, I was saying the nearest neighbors are 1, 2, 3. But of the nearest neighbors, 2 of them are the red triangles and 1 is the blue square. So it is highly likely that the new data point is a red square. So that is how k nearest neighbors operates. So this is just a visualization. To have an idea about the details of k nearest neighbors, please refer to k nearest neighbors classifier. So these are just like follow-up research that you should, I highly recommend that you should follow up with and to see like what are the actual implementations of this model. But right now I'm just doing a basic introduction, very high level of what algorithms we shall see, because next I'm going to look at some code examples of how to build a supervised learning, machine learning example and how some data was analyzed. Okay, so far we've looked at a simple introduction of machine learning, we've looked at supervised learning and unsupervised learning, just definitions, but we're delving into supervised learning. So unsupervised and under supervised learning, we've looked at regression, and then we've looked at classification. And then on top of that, we've also looked at what are the business use cases of where you can use supervised learning. And then now we are looking at what are the different algorithms under regression, what are the different algorithms under classification. So under regression, we've looked at the very simple example of a linear regression. There are several other examples like logistic regression, ridge regression, lasso regression, and now we are looking at the different example algorithms under classification. And remember that regression is when you're trying to predict a continuous variable, and then classification is when you're trying to predict a categorical variable. So under classification, now we've looked at logistic regression as the first algorithm. We've looked at k-nearest neighbors as the second algorithm. Then we've looked at support vector machine. Now we're going to look at support vector machine as, I think, the last example of a classification algorithm. So again, disclaimer, this is very, very high level, very introductory, and I really would not like to, of course, go into complexities at this point. So this is just to get you interested. See, okay, now when you go and research, how many more algorithms are there under classification, supervised learning? How many algorithms are there under regression? And how do these algorithms work when I put an input and then, or a set of inputs, and how does it give me an output? Okay, so now let's look at the last example of classification algorithm, and this example is called a support vector machine. Okay, so we usually call it an SVM. So an SVM is a powerful machine learning algorithm for data classification. The point of SVMs are to try and find the line or hyperplane to define a dimensional space, to divide a dimensional space which best classifies data points. Okay, so we're going to an explanation. So if we're trying to split two classes A and B, we would try to separate the two classes with a line at best. Okay, so like before, remember in linear regression we were saying, okay, this is our data, and if we try to plot our data on just an x and y axis, the quantity of the output variable is going to be determined by the line that best fits the data. But now, on the flip side, we're saying, okay, in support vector machine, if we're trying to split two classes, we would try to separate the two classes with a line that best fits. So if you try and plot the data points on like a XY axis, we want to say, okay, these classes belong to class A. I mean, these data points belong to class A, and these data points belong to class B. At the very best, very simply, we would want to draw like a line that separates the two. So that line will be the one that will help us in classifying. Like in case a new data point comes in, we are going to say, okay, because it's below this line, it's class B. Because it's above this line, it's class A. But finding that line, as we shall see, let's see how the explanation builds. Okay, so if we are trying to split two classes A and B, we would try to separate two classes with a line at best. On one side of the line or hyperplane would be data from class A, and on the other side would be data from class B, like I've just explained. This algorithm is very useful in classifying because we must calculate the best line or hyperplane once, and any new data points can easily be sorted by just seeing which side of the line they fall on. This contrasts to k-nearest neighbors algorithm, where we would have to calculate each data point's nearest neighbors. Okay, so support vector machine, so hyperplane is going to be for, like, sometimes you don't just have like an XY, sometimes you have an XYZ axis. So that's why they keep saying the baseline or a hyperplane. All right. Okay, so at the very simple, so quite simply put, for support vector machine, they are trying to draw a line between data points, and that line is supposed to divide and say, okay, once the data point belongs to above this line, it is going to be class A, and if it's below this line, it's going to be class B. Okay, so a hyperplane depends on the space it is in, but it divides the space into two disconnected parts. For example, one-dimensional space would be just a point. A 2D space, 1D is just a point, a 2D is a line, a 3D is a space, just like I've just said. Like if you have X, Y, you have a line. If you just have one point, one-dimensional space, it's just a point. 3D, that is X, Y, Z, would be a plane, and so on. Okay, so you would be wondering that there could be multiple lines that split the data well. In fact, there are infinite amount of lines that can divide the two classes, as you will see in the graph below. Every line splits the squares and the circles. So which one do you choose? Yeah, so like you can see here, this line splits the blue and the red, and then there's just this line, then there's this line, then there's this line. The blue class can be separated from the others. Okay, then there's also the white one, which can be separated using this line between the red and the white. So how does SVM, support vector machine, find the ideal line to separate the two classes? It doesn't just pick a random one. The algorithm chooses the line, hyperplane with the maximum margin. Maximizing the margin will give us the optimal line to classify the data. So take a look at the figure below for visualization. All right, so that is just delving a little bit deep into how support vector machine works, but at the high level, what it does, it finds the best line that divides the data between the 2 or 3 categories. Okay. All right. So this is just a summary. In this article, we addressed the notion of supervised learning as a category of machine learning. We explained what machine learning is and why experts call it supervised. We described the steps to develop a machine learning model aimed to perform machine learning, as well as what is the purpose of supervised learning. Then we divided supervised learning into 2 general categories: regression and classification. Finally, we discussed popular machine learning algorithms associated with each of the categories mentioned above. I hope you enjoyed the article. The description of machine learning algorithms in this article was initially written as part of our machine learning course. Please refer to the associate project to see the details. Okay, there's a whole lot of resources that you can go and follow up on. Okay. Yeah, but really that is a high-level introduction, and I hope like now when someone says, okay, k-nearest neighbors, you can have a good understanding of what it is and how it classifies. Okay, so now we are going to go through an example. This is the Titanic data set. We are going to go through an example. It was put on Kaggle. Kaggle is like one of those sites where they put data sets and people try to approach them and say, okay, how do we approach these data sets, and which models do we train, and then highest accuracies are given, like prizes or something like that. You can go and find out about Kaggle if you don't know about it. All right, so yeah, let's look at this Kaggle competition for the Titanic data set. And this is just data that was collected about the people who are on the Titanic, the ship, is it a ship? The cruise. And the point is to predict, did this person survive or did they not survive? Okay. All right, so we shall just go through very simply. This is a very baseline approach, and it's just trying to introduce you to the process, like the whole pipeline, from when you get the data set, how you explore it, and then how you clean it, how you get the features, and then how you try different classifiers, and then